So you remember from last time, adding opposites, what it does is takes away that number that's being added. So 8 plus what gives me 0? 8 plus negative 8. Negative 12 plus what gives me 0? Star plus what gives me 0? Negative 1/2 plus what gives me 0? So again, remember we use this idea to get rid of the added number that is beside the variable when we deal with add and subtract equations. M plus negative 7 equals 12. I need to expand the side that's with the variable. M plus negative 7. I need to drop in a number that will make the negative 7 disappear to 0. Whatever I add to one side, I must add to the other. I want to get M all by itself. So add the opposite of the number with the variable, 7. Add it to both sides. I will get 0. Negative 7 and 7 add up to 0. Cross them off. I'm left with M by itself. On the other side, I get 19. Try this example. Now we want to start taking a look at the next rule, multiplying by reciprocals. What this will do is help get rid of a multiplied number, and it will turn it into 1. And there's reasons for that. We'll get to it. So we have 3 over 4. I need the reciprocal of 3 over 4, because when I multiply it by its reciprocal, I will get 1. The 3's will cross off. The 4's will cross off. And I end up with 1 across, and I get 1. The next number is 6. Write 6 as a fraction, which is 6 over 1. What is the reciprocal of 6 over 1? 1 over 6. The 6's cross off, and I'm left with 1. The next fraction, flip it, I end up with 11 over 7. What about a mixed number? It has to be improper first before you can flip it to find its reciprocal. Make it improper first, multiply it by its reciprocal, and I end up with 1. So we're going to use this concept to solve multiply and divide equations. Remember, subtraction is a myth. It doesn't exist because you can change things to addition. Same can be said about division. My first example is 3m equal 42. Remember, a number beside a variable means multiply. 3 times m equal 42. So what I'm going to do is make a new line of work. This is where my algebra steps go in. Instead of adding opposites, because it's multiply, I'm going to multiply by the reciprocal. Put a multiply sign to both sides. And I need the reciprocal of the number that is with the variable. The number is 3. 3 as a fraction is 3 over 1. So the reciprocal of that is 1 over 3. If I do it to one side, I have to do it to the other. I want to get m by itself. The 3's will cancel out. I'm left with only m. On the other side, it's like multiplying fractions. Can I reduce diagonally? Yes, I can. Divide both by 3, I get 1, and I get 14. So I end up with my solution, m equal 14. Notice I multiplied both sides by the reciprocal of the number that's with the variable. Now let's take a look at another example. This also works with division. M divided by 4 equals -6. I am going to multiply by the reciprocal of the number that is with the variable. The number that is with the variable is a 4, but notice where the 4 is at. The 4 is underneath or in the denominator of the fraction. So with that being said, where does the reciprocal of the 4 have to be? It can't be on the bottom, it needs to be on the top. So we will rewrite and multiply by the reciprocal. The reciprocal of a 4 in the denominator is a 4 in the numerator. So I will write times 4 over 1. If I do it to one side, times 4 over 1, I must do it to the other side, times 4 over 1. Pay attention that it's not 4 over m. Reciprocals should only be dealing with the number that is with the variable, not the variable itself. Again, reduce diagonally, multiply, and you end up with your final solution.